Hi guys, it's still Mr. Richard. We are on paper 1, right, November 22. We are creating the memo for it. Right, let's put this into practice. If you are new to this channel, what are you waiting for? Let's subscribe and grow the community. We really appreciate your subscription, guys. Let's grow this community. If you're new to this channel, let's go. 1, 2, 3. Subscribe. Thank you, thank you. We can start killing these people now. Right, okay. We are at 1.1 there. We are given 3x minus 6 and x plus 2 is equals to 0. So this is a product. My paper is messy. I just got it from a student, but don't worry. Don't worry. Let's tackle these questions. Right. We have 3x minus 6 and x plus 2 equated to 0. Okay, we shall put that into practice. 3x minus 6 as well as x plus 2 is equals to 0. Equate everything to 0. 3x minus 6 equated to 0, or x plus 2 equated to 0. So from there, we can just take negative 6 to the other side. It becomes positive 6. Then to make x the subject, we divide both sides by 3. And, okay, x will be 2. Right. Okay, we are done with that. Let's transpose 2 to the other side so that we make x the subject. It's going to be negative 2. So after that, guys, you can just take this values and plug them here. They will give you 0. That's where you can confirm that your answer is correct or not, right? So let's go to 1.1.2. At 1.1.2, we are given 2x squared minus 6x plus 1 equated to 0. So it is set correct to 2 decimal places. Well, when you're given such equation, it's either you can use completing the square or you can use a quadratic formula. I prefer to use a quadratic formula. Remember that it's 2x squared minus 6x plus 1 equated to 0. So this is a quadratic equation. A is 1, B is negative 6, and C is equals to 1. Then we can use a quadratic formula then. It says x is equals to negative b plus or minus b squared minus 4ac divided by 2a. Where there is b, we shall put negative 6, right? Plus or minus there. Therefore, it's going to be minus 6 squared there. Where there's a, we shall place 2. Where there's c, we shall place 1. Be very careful when you substitute. Similarly as here, we are going to place 2. So what are we going to have? Negative 6 and negative times negative 6, that's going to be positive, plus or minus root 2 times 2, that's going to be 4. So let's work out the thing that is inside the brackets. Negative 6x squared minus 4, 2 times our c is positive 1, right? What are we getting there? We are getting positive 28. So they said we need to leave our answer into 2 correct deci places. Okay, we are going to have 2 solutions. So when you say 6 plus root 28 there divided by 4, you are going to have 6 plus root 28 divided by 4 correct to 2 deci places. That will be 2,82. So we are going to have 2,82. Okay. Then when we subtract it, we are going to have 0,18. Yes. Just be very careful when you substitute. So those are the values that will be when you are working with 1.1.2. Right. So now let's go to 1.1.3. Okay. 1.1.3, it's an inequality. It's x squared minus 90, which is greater than x. How many marks? Also, it's going to be 4. So when you are here, you need to write this in a standard form. Take x to the other side. It will become x minus x and minus 90, which is greater than 0. We are not done. We are not done when it's like this. So what we could do is factorizing. Yes, we could factorize, find the factors of 90, I mean. So that will be x and x and x okay, which is greater than 0. So from here, we need to find the factors of 19. Definitely that should be 9 times 10, 10 times 9, right? So that will give us a minus 1. That could be, let's see. Okay, if we have negative 10 plus 1 plus 9, that will give us, if we make 10 as negative and we make 9 as positive, because when you say negative 10 times plus 9, negative 10 plus 9, that should give us satisfy this middle term. So it should be, in this case, it should be negative 1, right? So, and when we say negative 10 times 9, it will be negative 90. So equate everything. Let's find CV, critical values. So x will be 10, or x will be minus 10, minus 9, right? So from here, we need to write the solution graphically. Okay, we can write this. Okay, so this will be minus 10 and 9, right? Okay, so it's very, very, very important that you check whether it's going above, or this symbol tells us that the solution will be above the x-axis, right? So it's very, very important to do that. Okay, let's we are going to shade here. Okay, or some of you may use table of sign is also correct when you use that. All right, let's check the signs. Oh, I realized that I'm making a mistake here, guys. It means that 10 should be positive. Okay, ish, silly mistake then. Silly mistake though. So why I'm saying so, 10 minus 9 is going, okay, let me see. Am I making a mistake? Oh, it's good to check. Let's check. It should be negative 9 plus 10. Okay, 10 should have a positive sign. Yes, that's good. So, okay, right, okay, let's check this. I was saying that I made a mistake here. Okay, it was right. Actually, this should be minus 10 and plus 9. Okay, so we are going to have negative 9 here. And, oh, sorry for that. You see, guys, you should check. Okay, what am I doing here? I should, oh, keep making silly mistake. Let me just draw it here. Sorry for that, sort of because of space. 10 will be positive in this case, then x will be negative 9. So in this case, we are going to have negative 9 there. We're also going to have 10. So let's look at the sign here. The sign is going above, so meaning that, okay, we can shade here the side. Okay, it's going above, or we could leave it in a table of signs. So usually say negative 9, some will use 10. So this will be like this, and you're going to have something like this. It's positive sign here, and then at the middle between negative 9 and 10. Yeah, so mind your mistakes, guys, while you're writing. Check, please, so that you don't make mistakes. So you saw that in this question 1.1.3, I made a mistake, and I was able to rectify it. Let's go to 1.1.4. At 1.1.4, what type of inequation is this? Where x minus 7 root x is equal to negative 12. Well, guys, this is what we call rational exponent. It's an equation without a base. Yeah, this is a rational exponent. First thing first is to write this thing in standard form. Let's put this into practice. We are in 1.1.4, so this will be x minus 7 root x, which is equals to negative 12. Okay, so this will be x 7 x half plus 12 equated to 0. So from here, check which one that has a high exponent. Definitely it should be x to the power of 1. How many halves do we have here? We have 2. So the simplest way you can just say let k be x half, meaning that here we'll have 2 x half. So it's going to be k squared minus 7k plus 12, which is equals to 0. So we'll then solve for k. So since it's positive here, we'll have same sign. We're going to have negative 4. We're also going to have negative 3. okay, equated to 0. Negative 4 and negative 3, that will give you minus 7, right? And negative 4 times negative 3, that will give you positive 12. Definitely, this is cool. Then when you equate everything to 0, you're going to get 4, you're going to get 3 here. We are not solving for k, we're solving for x. Therefore, go back there. X half is equals to 4. Then the inverse of this will be 2 all over 1. Similarly, we can apply that here. When you apply that there, we can have, you can change 2 to the power of 2. That will be 2 times 2, which is 4. 2 to the power of 4, that will be 16, right? Or you could just say x half is equals to 3. Then the inverse of this will be 2 to the power of 1, and this will be 3 squared. This and this cancel, this and this cancel, then you're left with 3 squared, that will be 9. Then you can check here. If they give you negative 12, therefore that means they are correct. Now we will go to a simultaneous equation in 1 point. It's not 1.5 there, it's 1.2. Okay, they said solve for x. 2x minus y is equals to 2. xy is equals to 4. That will be 5 marks, right? You can't afford to lose such marks, guys. So you have 2x minus y is equals to 2, and you have xy is equals to 4. So the first thing first, we need to make this. You need to choose an equation that is easier to work with. In this case, the equation that is always easier to work with, it's a linear equation, right? So we can change this by making y the subject of the formula. So in this case, it can be negative y is equals to, let's take 2x to the other side. It will become 2 minus 2x, right? So when we divide both sides by negative, we are going to have negative 2 plus 2x. So when you write it in a standard form, it will be 2x minus 2. So we name this equation 1. So what we could do is to substitute equation 1 into 2. So meaning that where there is a y, we shall put 2x minus 2. So we could say x multiplied by 2x minus 2 equated to 0. Okay, so from here it's going to be 2x squared multiplied by x, everything that is inside the bracket. It's going to, so here it's 4. Don't forget that. It's 4 there. So let's not make a mistake there. This is 2x. Let's take 4 to the other side. It becomes minus 4. Then we can divide everything by 2. 2 is divisible to all in this expression. So in this equation, then we divide, it will divide by 2. It's going to be x squared minus x minus 2. Right. All right. So now we need to factorize, right? When we factorize, what are we going to get here? The factors of x squared is x, the factors of x it's x, there the factors of 2, that will give us minus 1. We can say negative 2 plus 1. The factors of 2 is 2 and 1, right? Negative 2 plus 1, that will give us negative that will give us negative 1. So in this case, we can have x minus 2 and x plus 1 equated to 0. So be very careful. Then when we equate it by 0, we are going to get x is equals to 2 or x is equals to negative 1. We are not done. We need to find the y values. Go back to the equation that we have changed to be equation 1 there. Let's plug in 2 to this equation. Let's say 2 times 2. Okay, 2 times 2, that's going to be 4. 4 minus 2, that's going to be 2. Okay, all right, then let's go to the other one. 2 times negative, replace with negative 1 now. Okay, 2 times negative 1 is going to be negative 2. Minus 2 is going to be minus 4. Well, you can check these values here. Definitely, they will give you. You will see that they are correct. So normalize checking, guys. Normalize checking and avoid silly mistakes when you're working with sites so that we get full marks, right? So we are going to 1.3. Show that 2 times 5 to the power of n minus 5n plus 1 plus 5n plus 2, it's even for all positive integers of n. Guys, even numbers are numbers that are exactly divisible by 2. So when we simplify this, we must make sure that it is divisible by 2. The integers that we can plug in are divisible by 2. Let's put this into practice. All right, then we need to show that it's even for all positive integers. Remember what I told you about integers? Numbers are integers that, even numbers are integers that can be divisible by 2, right? So in this case, let's first thing is to break this. Yes, using the laws of exponents, this will be 5 to the power of n and 5 to the power of 1, 5 to the power of n and 5 to the power of 2. What is common? It's 5n, right? So we are left with 2 here. Here we are left with minus 5, because 5n times 2 is 5n, and 5n times this will results to this. So to get, we also 5 squared, that will be 25. Okay, so in this case, what can we do? 5, okay, you can, since we are simplifying, okay, 2 minus 5 plus 25, what is that? That will be 22. 2 minus 5, that will be 22s, right? It's the same as having negative 5 plus 25, the same as 20 plus 2, that will be 22. Okay, so we can, 22, sorry for that. We can just factor out, we can just say 2 times 11 times 5 to the power of n. 2 times this, okay. Then let's plug any integer that here. If we plug, try to plug 1, let's see. 11 times 5 to the power of n times 1. That will give you 110. And divide that 110 by 2. Yes, so this is applicable. This is applicable. Then let's work with 1.4. Determine the values of x. Yes, determine the values of x and y. It's the same as simultaneous equation. First thing, guys, we need to get rid of a fraction. So I'll show you a way how you can get rid of a fraction when given such equation, right? Right. Okay. We are on 1.4. This is the last question on question 1. Yes, in question 1, on question 1, determine the values of x. So we're given 3 to the power of y plus 1, which will be 32 is equals to root 96 to the power of x. First thing, guys, you need to get rid of a fraction by multiplying both sides. Therefore, I said that we multiply both sides by 32. So it's going to be 3y plus 1, so which will be 32 here, multiplied by root 96x there. Okay, so we are going to say 3 to the power of y plus 1 is equals to 32. Okay, the first thing is to get rid of a square root. We can take a root by half. So we are going to have 96 x here and half. So let's multiply out using the laws of exponents. 3 to the power of y plus 1 is equals to 32. This will be 96 x half, right? Because x times half, it's x. 96 all over 2, sorry for that. So when we are here, we can break 96 then. 96, it's the same as 3 times 32. Yes, 3 times 32 there. 3 times 32 will give you 96, right? Okay, and x half, and x to the power, and x all over 2. I keep saying x half. Okay, 3 to the power of y plus 1 there. So okay, we need to follow the rules. What we could do, the rules of exponents here, this will be 3 to the power of x half, and this will be 32 to the power of x all over 2. Okay, so we have 3 to the power of y plus 1. What are we having here? What we could do, it's quite simply, we could just change 32, right? But before we change 32, I would like us to, we can see that we have the same basis. We add the exponents, we have the invisible one here. So in other words, we are going to have x all over 2 plus 1. Remember that it's 32. multiply by 3x all over 2, which will be 3y plus okay, which will be 3 to the power of y plus 1 there. So what we could do is to change 32. When we change 32, it will be 2 to the power of 5, and x all over 2 plus 1 times 3 to the power of x all over 2. Okay, so we have 3 to the power of y plus 1 there. So let's work out this. This will be 5x all over 2 plus 1 and 3x all over 2. What is interesting is that we do have same basis of 3 there, but we don't have that one of 2. So let's make it will be 2 to the power of 0. We can put 2 to the power of 0 so that the bases are, we have the same basis, right? So it will be 2 to the power of 0. Therefore, we have 3y plus 1, okay, is equals to, which is equals to what? Oh, the bases are the same, sorry for that. Okay. When the bases are the same, what should we do? We should say y plus 1 is equals to x all over 2, okay? So from here, similarly with this, it's going to be 0, which will be 5 all over x all over 2 plus 1. We can multiply both sides by 0 there, by 2. Okay, what we could do, it's quite easier. We can just take 1 to the other side. It can be negative 1. We will have negative 1 and 5 all over 2, 5x all over 2. Then we can multiply both sides by 2 here. Multiply both sides by 2. What are we going to get? We're going to get negative 2. This and this, they cancel. We are left with 5x, right? Let me write it in a clean page. So let me write the remaining steps in a clean page. But before I write it in a clean page, let's check whether we did everything correct. 5 times this, it's this. 5 times 1, it's 5. So that means I made a mistake there. Let's go to a clean page then and apply what we have done here. All right, let's put this in a clean page so that we can see what is what, right? We have the same basis. We can drop the exponent, which is y plus 1. I started with 3 now, which will be x all over 2. And we have, what are we having there? 2 to the power of 0. So that will be 0 is equals to 5 all over 2x plus 5 there. We could take 5 to the other side. It becomes negative 5. Okay, we have 5 over 2x. Then we can multiply by 2. That will be negative 10. Then we're left with 5x. Then divide both sides by 5. Therefore, x should be, how many times does 5 goes into 10? It goes twice, so x should be negative 2. We can take this negative 2 and substitute here so that we can get y, right? So when we are done there, we should take negative 2 and place it here. Negative 2 divided by 2, what would be that? That will be minus 1. Then let's take y to the other side. Let's take 1 to the other side. It becomes negative 1 minus 1, which will be minus 2. Okay, so that's how you were supposed to solve that equation, right? So we can substitute. Remember that we did get our x as negative 2 and y is our negative 2. You can go back there at this equation, plug negative 2 where that is y and plus 1 divided by 32. Definitely you get 1 all over 96. Okay, let's see the other side then. 96 to the power of negative 2. Definitely you get 1 all over 96. So that means it's correct. See you on the next video where we are going to discuss patterns. Hope you find this video useful and don't forget to subscribe. And remember, we love you.